let's do 5 long division problems to round out the examples for the week. Out of section 2.4 on page 365, I'm going to do problems 2, 6, 13, 14, and then I'm going to do one more problem that I made up just for this video. I've already summarized the problems on the whiteboards, though you should check out how they're stated in the book, because some of them are stated as quotients rather than as long division problems. So if you check out 14, it's written as a quotient, and you should just go on and check that out and make sure you agree with how I've translated things here. But I just want to get started with the long division. So here I need to know how many times x goes into x squared, but what I always like to think about is what do I multiply x by so that I get exactly x squared? And I multiply it by x. And I just distribute, and now I need to change all of those signs to subtract. The x squareds cancel out, and that should always happen when I'm doing long division of polynomials. That is by design. 3x and 2x give me a 5x, and I need to bring down that minus 10. All right, I need to multiply x by something to get 5x. Well, that will have to be a positive 5. And I get exactly what I have written above it, so when I change all of the signs, I get a remainder of 0. So I've actually answered the question because here I was actually just asked to state the quotient and the remainder, so I've done that. But I'm going to go one step further because what I originally had was a division problem. I divided x squared plus 3x minus 10 by x minus 2, and I found out it went in there with a remainder of 0. It divides evenly. So now I know that x minus 2, the divisor times the quotient, is what I started with. Because the division algorithm would say add the remainder, and the remainder is 0. Divisor times quotient plus remainder equals the function. That's nice. Remainder 0 means I have something that is evenly divisible. And that's one of our goals here, is to get good at division so that we can factor more things. All right, so in number 6, 3x plus 4 divides into x cubed plus 17x squared plus 27x plus 20. How many times does 3x go into 6x cubed? Well, 2x squared times. So again, I multiply, just thinking about distributing. Now I need to change all those signs to subtract. The 6x cubes cancel, and I'm left with 9x squared when I do the subtraction here. And then I need to bring down a 27x. All right, I need to multiply 3x by 3x to get a 9x squared. Let's change those signs to subtract. The 9x squareds cancel, and here I'm left with a 15x. Bring down that positive 20. And I need to multiply this by 5 so that I match that 15x here. And again, it's almost too nice. I get a remainder of 0. Quotient remainder. But again, the big thing I could claim here is that the function that I'm dividing into, the dividend or numerator, is equal to the divisor times the quotient plus the remainder, which here is 0. So again, I'm in that situation where I have something that divides evenly into something, so I get 2 factors. So there is 6 and 2. Next up, 13 and 14, and then finally the one more problem that I promised you. So just 2 more long division problems. In number 13, well, I'm going to proceed the same way I did last time. I need to know how many times 3x squared goes into 6x cubed. And again, the way I like to think about that is what do I multiply 3x squared by to get 6x cubed? Well, that would be a 2x. Let's extend that division bar out just a little bit. 6x cubed minus 2x squared. Finally, minus 6x, but I need to change those signs to subtract. Those cancel. I get a 15x squared. And then finally, minus 5x. And we need to bring down that minus 15. All right, I need to multiply this by 5 to get that 15x squared. And again, it's almost like some of these problems from our text were too nice, like the author was just trying to get us to realize that we get a bunch of remainder zeros, which means we have a bunch of things that divide evenly into something else. So again, we're in the situation where I have the numerator is equal to what I'm dividing by times the quotient, because the remainder is 0. All right, in number 14, finally I'm going to get a remainder that is not 0. Spoiler alert. All right, so I need to multiply x squared by x squared to get that x to the 4th. And again, I just keep distributing. I need to change all of the signs to subtract. And we'll bring down that minus 5x. All right, so I need to multiply that by x to get that perfect x cubed sitting right there. Don't know why I said perfect, but it is a perfect x cubed. Don't know what other kind there is. Change all the signs to subtract. Those cancel. I get a minus 3x squared. I get another minus 3, but this time I've just x. I have to bring down that minus 6. All right, I need to multiply x squared by minus 3 to get that minus 3x squared. And then finally here I get a plus 6. Change the signs to subtract. And I get a remainder of minus 12. So I have a quotient this time. And finally a remainder that's not 0. So this time I'd have x to the 4th plus 2x cubed minus 4x squared minus 5x minus 6 is equal to x squared plus x minus 2 times the quotient x squared plus x minus 3 minus 12. Man, I wish I had room to write minus 12 right there, but that's the equation. X to the 4th plus 2x cubed minus 4x squared minus 5x minus 6 is equal to this product, but take away 12. Let's just see if I can make that look a little nicer by cheating and using the board below. Minus 12. There's that nice, happy polynomial function. All right, well, there's just one more I wanted to do, right? Because I said I was going to do problems 2, 6, 13, 14, and then one more. So it's time for the one more. I just felt like we hadn't seen enough of these that had remainders that weren't 0. So I wanted to do one more. And so the one more I want to do is x squared plus 2x plus 3 dividing into x to the 4th plus 7x cubed plus 10x squared plus 11x minus 12. Just so that we see a more interesting remainder. All right, well, I start off the same way. Let's multiply by an x squared so that I get this x to the 4th here, so those will cancel off. Change all the signs to subtract. All right. So now I need to multiply everything by 5x to get that 5x cubed sitting there. Change all the signs to subtract. Bring down that minus 12. All right, I need to multiply this by a minus 3 to get that minus 3x squared. Let's change those signs to subtract. So these cancel. I'm left with a, hang on just a second, I think I have a sign wrong. Here at the very end of the video, I want to back up a step, fix that mistake. So let's see. I brought down the minus 12. I need to multiply through by a minus 3. I get minus 3x squared. I get a minus 6x, and I get a minus 9. Let's change those signs to subtract. Oh, that looks a little better. All right. So those cancel out. That's by design. That should always happen. And now I get a 2x minus 3. And there's my nice happy remainder. So this time I have a quotient. And a remainder that's not just a constant, and that's okay. Because the only rule for my remainder is it has to have a degree that's lower than the degree of what I'm dividing by. Since I'm dividing by a quadratic, I could either get a linear remainder, degree 1, or something that's a constant, which would have degree 0. But that's it for now.